Hi, my name is Benedikt Spielmann. I'm Product Manager for Digital Communication here at GF Piping Systems. Today, I would like to give a very short insight how an EtherNet network looks like, which components are necessary, and how this technology works in combination with our GF Piping Systems actuators. In this example, we are focusing on EtherNet IP, which is an open communication standard managed by the ODVA Association. Let's take a look on the components which are necessary to set up such a network. In this example, we are using a PLC of Allen-Bradley. It's a compact logic with Ethernet ports directly at the CPU, which means the Ethernet IP language can be spoken directly here to the PLC. There is no separate interface card and especially no expensive input-output card necessary to connect the field devices. The next component here, it's an Ethernet switch. It's an optional device, but it's always recommended to use one in terms of troubleshooting, security, redundancy concepts, and so on. In this example, it's also from Allen-Bradley, but there's a huge variety from different vendors and with many different functionalities available on the market. As we can see, the PLC is directly connected to this Ethernet switch. And from the Ethernet switch, we are going down to the field level. So in this case, to our electric actuator, which speaks also Ethernet IP in this case. So the Ethernet devices themselves, they are obviously also required to set up such an Ethernet network. For the interconnection of all the different Ethernet devices, we need the Ethernet cables. For the use in industrial environments, those cables are called industrial Ethernet cables. You need at least the category 5, but you also can use higher categories. In terms of connectors, there are two different possibilities. One is the well-known RJ45 connector, which you might know from your office or home installation. Alternatively, and much easier for the connection of the field devices, it's also possible to use an M12 connector with the decoding. This is also what we can see here in our setup. So we are going from the Ethernet switch with the Ethernet cable to the first Ethernet device, which is the electric actuator in this case, connected via an M12 connector. As the device itself provides two Ethernet ports, we can set up the so-called line topology. So we are going in with one cable, going out with another one to connect the next Ethernet device. This could be another GF actuator, but it also could be any kind of other Ethernet IP device, like a frequency converter, for example. Here, in this example, we have the positioner for pneumatic actuators, which can be mounted on top of a pneumatic actuator. This is available at GF for stroke actuators, but also for rotary actuators. The maximum cable length between all of those Ethernet components, it's up to 100 meters, roughly 300 feet. Which fits to many use cases in our kind of industries. Even if the maximum cable length is not sufficient, it's quite easy to extend the cable reach by adding additional Ethernet switches. There's a lot of additional data available with electric actuators in combination with the Ethernet technology. Besides the normal open-close functionality, there's also the possibility to bring the valve to a certain percentage value between open and close, so the typical positioner mode. Besides that, there's a comprehensive diagnostic capability, which means we have a device status which displays the device health. In this case, we are simulating that a manual hand wheel is plugged in, and this information is directly possible in any kind of customer environment. Additional data from the electric actuator can be displayed, but also monitored over a certain time period, which makes it very easy to identify any abnormalities of the valve or of the process. So if the motor current, for example, exceeds a certain limit, you can be quite sure there's any kind of issue at the valve. Many configuration possibilities are available to set certain limits, for example, to steer the motor current monitoring or the cycle time monitoring. We also have features like the action on signal loss, which brings the valve to a safe position in terms of an interrupted Ethernet communication. The integration of the Ethernet devices to the PLC works by a dedicated device driver. In the context of Ethernet IP, it's the so-called EDS file. You can find that file via our GF website, but it's also embedded in the device itself. You can access it by accessing the embedded web server. And this is exactly the next step I would like to present. It's very easy to access this web server. Everything you need is a direct access to the local network by plugging in an additional Ethernet cable and a laptop where you can open the embedded web server. Connect to the embedded web server, enter the individual IP address of the electric actuator to a standard web browser. Roles and passwords prevent unauthorized access to the embedded web server. The administrator role has write access to the parameter values. The system overview provides the most important live data from the electric actuator, such as the actual position, the motor current, and the total number of cycles. Static device information, such as the serial number, is also displayed in this overview. Diagnostic events are visualized by NE107 status, a clear description of the event, and the timestamp of the occurrence. Configuration of motor current and cycle time allows a process-specific monitoring. Factory reset, restart, and even firmware updates, everything possible without direct device access. The event workbook tracks up to 5,000 device events, which includes both diagnostic events and general events, such as parameter changes. The electric actuator provides static downloads, such as the user manual, the device driver for the PLC integration, but also generated reports with all parameter values, which can be used as documentation after commissioning. The event logbook is also part of this report. The embedded web server creates added value and is security certified according to IEC 62443.